Right now, as you watch this, 3I Atlas is moving toward the Sun on a trajectory that's anything but random. When scientists first tracked its speed, over 200,000 kilometers per hour, they realized it couldn't possibly have originated from within our solar system. In exactly 12 days on October 29th, it will pass its nearest point to the Sun, a stage astronomers call perihelion. But here is what keeps Harvard astrophysicist Avi Loeb awake at night. This visitor might not depart. New estimates indicate it could use the Sun's gravity to slow and capture itself within our local space, for good. If that occurs, Loeb warns, global markets could tumble as people face a reality we have never had to face before. Yet that is not the most troubling part. Fresh measurements point to something far more disquieting about what the object may be, and what it could do while it hides behind the Sun. So the puzzle becomes whether we are seeing a natural comet or a crafted machine. I will lay out what is happening, because the math traces a pattern that is growing harder to set aside. When astronomers plotted 3I Atlas's trajectory, they found something that defied probability. Instead of plunging in at a random angle like most interstellar debris, this object's path lies within just 5 degrees of our solar system, ecliptic plane, the thin disk where all our planets orbit the Sun. Statistically, that alignment should be extremely rare. Out of hundreds of random possible angles, the odds of hitting that near-perfect alignment are less than 2 in 100. It's like throwing a dart across a football field blindfolded and hitting a target the size of a coin. And yet here it is, approaching on a trajectory that makes it look almost intentional. Loeb's team believes this alignment might not be a coincidence at all. There is a known astrophysical principle called the Oberth effect. The idea that an object moving at extreme speed within a gravity well can use a small thrust to dramatically alter its path. At perihelion, 3I Atlas will be traveling faster than any known spacecraft, nearly 250,000 kilometers per hour. If it were to apply thrust even for a few minutes, the resulting change in trajectory could be massive. To understand this, think of a spacecraft performing a reverse slingshot around the Sun. The deeper it falls into the Sun's gravity well, the more powerful even a tiny engine burn becomes. If 3I Atlas does anything unusual while hidden behind the Sun, changes direction, slows down, or fragments into multiple controlled paths, we wouldn't know until it re-emerges weeks later. And that brings us to one of the strangest coincidences of all. During its approach, data from several major missions went dark. NASA's Mars Reconnaissance Orbiter, capable of imaging objects in incredible detail, was in perfect position to observe the object during its close pass by Mars earlier this month. NASA attributes the gap to a government shutdown that began just 2 days before the flyby. The ESA says their data is still being processed. China has released nothing at all. Across 3 agencies on 3 continents, the result is the same: silence. If this were just another comet, why the blackout? Here's where things get truly strange. New calculations from Loeb's research group suggest that 3I Atlas might not be solid at all. Based on its brightness and estimated size, the object should weigh nearly 250,000 tons, but its gravitational pull was barely detectable. For something that massive, its gravitational influence should have been measurable by multiple spacecraft. Instead, it was effectively non-existent. That means one of 2 things. Either it's made of some material lighter than anything we've ever observed in nature, lighter than industrial foam, or it's hollow. Think about that for a second. A hollow interstellar object the size of a small city entering our solar system, on a trajectory aligned perfectly with our planetary plane, approaching the Sun at an angle optimized for a potential orbital capture. The math fits, the observations fit. The only thing that doesn't fit is our assumption that it's a natural object. Loeb argues that the object's spin rate, brightness variation, and low mass all point toward a shell structure, something engineered rather than formed by random cosmic processes. In a recent paper, Loeb proposed what he calls the dandelion hypothesis, the idea that interstellar probes might not travel alone but in groups, each potentially carrying smaller payloads or microprobes designed to separate under ideal conditions. If that's true, then 3I Atlas might not just be a visitor, it might be a messenger. While Earth's telescopes are blinded by the sun's glare, anything released would remain undetected for weeks. By the time we regain visibility, those fragments could be spread across millions of kilometers of space, too far apart to recognize as part of the original object. That is the scenario worrying some astronomers, the possibility that 3I Atlas could be seeding our solar system with smaller objects, each on its own unique course. Now, before that sounds too much like science fiction, consider this. The first interstellar object ever detected, Oumuamua, also exhibited unexplained non-gravitational acceleration. It changed speed slightly without any visible outgassing. At the time, scientists couldn't explain it. Now we have another object doing something similar under even more mysterious circumstances. When 3I Atlas emerges from behind the sun, every telescope on Earth will be waiting. Its predicted path is well known. If it deviates by even a fraction of a degree, that data will appear instantly in the astronomical community. The Galileo project, led by Loeb, has already prepared observation protocols to track anomalous aerial and orbital phenomena correlated with 3I Atlas S timeline. That means if smaller probes do appear, or if any unexplained aerial objects show up in Earth's atmosphere around the same time, we'll have hard data to compare. It's the perfect natural experiment. For once, we don't need to speculate indefinitely. Within days or weeks of October 29th, we'll know if the data fits natural physics. If it does, this will go down as another strange but explainable cosmic event. But if it doesn't, if it behaves like a controlled craft, then October 29th could become a date humanity remembers for centuries. After the object's close pass by Mars on October 3rd, all eyes turned to NASA, the ESA, and China's Tianwen-1 mission for updates. The world expected high-resolution images, spectral readings, and gravitational data that would finally clarify what 3I Atlas really is. But instead, nothing. NASA's official explanation was bureaucratic: a government shutdown, communication delays, and prioritization of essential operations. Conveniently, those delays began less than 48 hours before the most important observation window. The European Space Agency issued a single statement saying data was under analysis. China's usually swift data pipeline released not a single pixel. Even amateur astronomers who had been sharing continuous tracking data suddenly stopped posting updates around that same time. In a normal scientific environment, such silence would be unthinkable. These missions share images of Martian dust storms within days. Yet when an interstellar object passes within visible range, we get radio silence. And that silence is exactly what has fueled speculation that something extraordinary was seen, something that the agencies either don't understand or aren't ready to explain. But this isn't just about missing data, it's about what those missing days could mean. Because between October 3rd and October 29th, 3I Atlas moves into the perfect position to disappear behind the sun. That means the moment it becomes unobservable is the same moment our best space-based cameras are either down or diverted. For most people, this might sound like a coincidence. For scientists who track objects with millisecond precision, it's an anomaly that raises alarm bells. When multiple space agencies go quiet simultaneously, the odds of it being random are almost non-existent. That's what led Loeb and several others to speculate that 3I Atlas might have already done something unexpected, something that could only be confirmed after it re-emerges. Let us step back and ask the big question. What if we re-witnessing the first contact event, not through radio waves or flashing lights in the sky, but through astrophysics? If an object from another civilization truly entered our solar system, it wouldn't need to announce itself. It could study us quietly, measure our technology, observe our planet's biosignature, and leave or stay without ever being seen. That's why this moment matters. Because for the first time, we have the instruments, data, and global collaboration to actually detect something like that. Whether the silence is because the data is inconclusive or because it is too extraordinary to release remains unknown. But one thing is certain. The next few weeks will tell us more about who we are in the cosmos than any government statement ever could. Because if 3I Atlas does anything unexpected, the entire world will see it together. October 29th isn't just a date on the calendar. It is a test of how ready we are to confront the unknown. Maybe it's just a comet, an icy traveler melting in the heat of our star. Or maybe, just maybe, it's something else. Something older, more deliberate, and infinitely more fascinating. Stay curious, stay observant, and keep your eyes on the sky, because the next revelation might be closer than we think. Do you have any predictions for what might happen on October 29th? Share your theory in the comments, because when the data returns in November, we'll compare notes and see who was right.